Hi, and welcome to this video on the topic of transverse and longitudinal waves. When we think of waves, we probably think of something like this. A wave is something which transfers energy from one place to another without a permanent motion of the material which the wave is travelling through. If you throw a stone into a pond, the ripples will spread outwards from the point where it strikes the water. The water itself isn't being moved from one place to another. If it was, it would bunch up at the sides of the pond. Next time you're in the bath, make a splash and see what happens to your favourite rubber duck. It'll bob around a little, but it will end up in the position it started off in, and so too will the water particles. We can split all waves into two main types, transverse and longitudinal. The word transverse means perpendicular to or at right angles to. In a transverse wave, the vibrations which cause the wave are at right angles to the direction of energy transfer. Have a look at this slinky spring as it's being shaken from side to side. Although the wave is travelling to the right, in other words, energy is being transferred to the right, the spring itself is vibrating up and down, perpendicular to the direction of wave motion. Important examples of transverse waves include light and all electromagnetic waves and water waves. In a longitudinal wave, the vibrations are parallel to the direction of wave motion. When you hear longitudinal, think along. We can produce a longitudinal wave on a slinky spring by pushing and pulling it forwards and backwards like this. Notice how the coils of the slinky are vibrating parallel to the direction of energy transfer this time. You might also notice that the metal coils have been pushed together in some places and pulled apart in others. In a longitudinal wave, a compression is where the particles that make up the wave are closer together than normal, and a rarefaction is where they're further apart. Sound waves are the most common type of longitudinal wave, so we'll take a closer look at how they work in a quick example. In part A, we know that the compressions are where the particles are more bunched up, and the rarefactions are where they're more spread out, so your labels should look like this. For part B, the answer is of course disagree. The sound travels from the speaker to your ears as a wave, and the particles in the air don't move permanently from one place to another. If they did, a vacuum would be produced near the speaker. That brings us to the end of this video on transverse and longitudinal waves. Thanks for watching and good luck.